Well, Rosemary, Joel is enjoying himself in sunny California, so it's just you and me for this episode, and we have a special guest here, actually. Rosemary, you want to introduce everybody?
Yeah, this is my little boy. He's 4.5 weeks old and just so keen to get started on engineering communication that he's decided to join the podcast today.
So we're excited to have him along with us, and we talk about some really interesting topics this week. Dominion Energy has finally settled with the state of Virginia on their offshore wind costs, and that's good news. Spanish regulators have agreed to let Siemens Gamesa be acquired by Siemens in a $4 billion plus takeover. And Siemens Gamesa is also trying to restructure itself as part of its Mistral program to really grow that company. And then we have, Rosemary, I go back and forth about some gravity-based foundations that are being installed in France, which is an interesting technology because it just lowers the cost of foundations. It's a little complicated in terms of how they're deployed, but it's lower cost, and you think you're going to see that in the United States. And then I crossed a video from ArcVera recently on YouTube, and everybody should subscribe to ArcVera's YouTube channel because they have really cool things there. But we talk about wake turbulence on offshore wind farms, and ArcVera has published some of their research in a long webinar. It's about an hour long, but it's well worth the time to sit through that and understand the difficulties and the concerns about wake turbulence on offshore winds. At the end of this, we have an interview with, Joel and I do, over in Germany. We sat down with Nicholas Gaudern, CTO of PowerCurve. We talk about pretty much all things aerodynamics, lightning, and wind turbine blades. So that's a really great interview. Stay tuned for that. I'm Alan Hall, president of WeatherGuard Lightning Tech, and I'm here with Australian blade whiz, Rosemary Barnes, and Joel's sunning it up in California. And this is the Uptime WindEnergy Podcast. Well, Rosemary, it's great to have you back. And Dominion Energy has resolved their dispute with the state of Virginia. Like I said before, when Rosemary comes back, the world starts to settle down a little bit. Things are calming down. There's less fires to put out, and one of them is this Dominion Energy state of Virginia issue. And remember that Dominion's going to put about 176 wind turbines off the coast of Virginia. And the state of Virginia, through some of the regulatory bodies, was asking for a 42% capacity factor, and Dominion said no, and very strongly said no. So that went back and forth, and they've been working to settle the disagreement, which is what a good company does. And they have agreed to look at capacity factor, but in a situational review. So if the capacity factor falls tremendously or by some defined amount, they're going to go to a board and have to explain what's happening. So for example, if they had some sort of serial defect in the wind turbines, they can go to the state and say, look, it's a serial defect in the wind turbines. We shouldn't be held responsible for something that we didn't do, right? That we're working to resolve it. Therefore, the state should give us some leeway. And it sounds like the state's going to do that. But there's also another little piece about the development costs because the state was concerned about how much money Dominion may come back and ask the state for this project, and they've set some parameters around it. But the parameters are very odd in a sense. So Dominion is responsible for the full cost of the project up to $10 billion. So between $10 billion or $10.3 billion and $11.3 billion, if the range goes somewhere in there, Dominion and consumers are going to pick up those costs. If it goes above $11.3 billion, Dominion is required to pay those additional costs. And then if it gets above the magic number of $13.7 billion, everybody goes, hold on, we're going to have a review. So there's $3.5 billion roughly of wiggle room in this development. So Rosemary, it seems like the capacity factor, which you said shouldn't be a thing, the capacity factor has been resolved, but they also have this development cost distribution graduated piece. Or you think this is going to get applied to other projects that are going on offshore in the US or other projects around the world now that this has been established as a framework?
It's interesting to see the three-tiered plan for if their construction costs overrun. And I think the top tier is like over 30% cost blowout, which ordinarily would be a lot. But I think that with a lot of projects going on these days, that's the sort of cost increase that you're regularly seeing now from, depending on how long the project planning duration is. But cost can definitely increase that much in a normal project timeframe now. So it wouldn't surprise me if we did get up to that. And then I guess we'll be in a situation similar to some of the other projects where you're all of a sudden, after years of planning and business cases and, making sure that everything makes sense, all of a sudden you've got a project that's too expensive to ever make money. I guess at that point you'll see the project cancelled, which I don't know, if you start to see a lot of that happening in the US offshore wind, considering that you don't have a lot of completed projects yet, it doesn't sound good for the industry and good for, getting companies to have confidence in the pipeline, the confidence that they would need to start building factories and, training workers and building ships and all that sort of thing, to implement the ambitious plans that the US has for offshore wind by 2030. So I think that's a big risk. I was really pleased to see that they didn't end up including anything to do with the capacity factor in their performance guarantee, because, that just made no sense. And I think that would definitely turn off future developers if that, set a precedent. So I'm glad to see that they got rid of that particularly silly request that they had. So, now we just wait and see how much prices go up to see whether this project will actually end up coming off.
One of the participants or co-signers in the Dominion state of Virginia dispute and the settlement was Walmart, of all companies, because they're one of the largest employers, maybe the largest employer in the state of Virginia, and they're one of the largest energy users in the state for sure. So I thought that was a little unusual that Walmart was actually involved in these negotiations at such a high visible level. It makes you wonder if companies like Amazon and Google and Facebook are involved in energy discussions with state regulators and the operators. Are they, because they use so much energy in different states, do you think they're at the table arguing for their company to keep energy prices low?
I think it probably differs on a case-by-case basis, depending on how much of the grid's energy that user is using. So traditionally, the large energy users were like aluminium smelters. I know that in New South Wales, the state that Sydney's in, the aluminium smelter at Tomago uses 10-15% of the state's electricity. And so they're absolutely involved in discussions about, how the grid's going to work and reliability. And there's agreements. And, from time to time, they reduce their demand so that, they can prevent blackouts and that sort of thing. And I think that the same thing happens with large energy users, especially where there's data centers and stuff that can use up a lot of energy. I visited one in Denmark where that was playing a significant role. It doesn't surprise me, and especially if those energy users have got power purchase agreements, PPAs, with the wind farm that make up a large, proportion of it, then of course they have a massive interest in making sure that the deal comes off and stays at at the price that is what that they agreed to.
Walmart may have had a hand in the capacity factor discussion. They may be in the one that was really driving it, because unstable energy would be a problem for Walmart, particularly for a data center.
And at the same time, if there's an agreement that drives the company bankrupt, then that is not going to be beneficial for any of those energy users either, because then they're going to not have the power that they have purchased. So I think that they're keen to see the agreement work.
Rosemary, since you've come back, Siemens has decided to buy the remaining third of Siemens Gamesa. And they've been talking about this for a while, actually. I think back in May, they introduced this concept of buying the remaining third. And there has been more of an effort on Siemens's part to right the ship in some sense, because they already own 2/3 of the company. So they offered another $4 billion, roughly, for a little over 4 billion euros for the remaining third of Siemens Gamesa. And they offered a premium of like 27% or roughly 25% over the existing share price. So that's a pretty sweet offer. And it sounds like Siemens, once this deal goes through and the Spanish regulators have approved it, which they have, that Siemens is going to take Siemens Gamesa off the stock market. So it'll be a privately held company, part of Siemens larger, which I think makes sense long term, just to get Siemens Gamesa rolling in the right direction. A lot of wind turbine OEMs are in financial straits at the moment. I think, and do you think, that the Siemens acquisition and just firming up Siemens Gamesa's books is a good first step?
Yes, I think so. From working in the industry, and I did little bits and pieces of work with some Siemens Gamesa projects, but not a lot. But just the general impression is that the cultures never really meshed that well between Siemens and Gamesa. And you definitely always knew if you were talking to a Siemens person or a Gamesa person. And so I think that from that point of view, and that continued for years and years after they merged. So even just from that perspective, it makes sense to me that they would try to not separate out again, but do something like this to resolve the cultural issue. Because normally when you merge, it's so that you can find some efficiencies and remove duplication and save money in that way. But since it still always felt like two companies, I can't imagine that they did that very successfly. So maybe this is an opportunity now where they can just be all Siemens. Siemens has, they basically, my understanding is they bought Gamesa, or they merged with Gamesa to get the offshore capabilities. Now they've got that. They've got a reputation for offshore now. I think that it makes sense and is... Yeah, I'm sure that the executives are looking at every option that they can to get costs down and profitability up in particular. And I think this is a pretty good approach to try that.
So over the last 12 months, Siemens Gamesa has signed about, I'm going to put this in dollars, all right? So it's about $12 billion worth of deals. They have a backlog of about $35 billion. And so the revenue for the last 12 months was about $10 billion. But they're going to lose over those 12 months. They're going to lose about $1 billion. So they brought in 10, spent 11, and they've had a program in place called the Mistral program, which was launched in the spring, that was giving them a way to create long-term stability. Now, as part of that, there's a reorganization that's happening starting on January 1st. So Siemens buying the controlling interest of Siemens Gamesa is in that timeline of January 1st. We're going to be in a little bit different position as an organization and financially. As part of this Mistral program, they're going to announce layoffs of roughly 3,000 people. But it doesn't sound like they're going to be so much layoffs as retirements early. It doesn't sound like they're going to be forced layoffs. It just sounds like they're just going to not hire people for a while. And they brought in a new person, a CTO, Morten Pilgaard Rasmussen. And on LinkedIn, when that happened, then when they made that announcement, there's a lot of chiming in with thumbs up for that. That engineers and technical people thought that was a good appointment. So things are going to look up for Siemens Gamesa. And Rosemary, you're right. The offshore bit of their business is where they're headed. And in fact, that's one of the 3 points they pointed out in a press release. They said offshore demand is going to be big and they want to be a part of it. And then they're going to try to obviously leverage some of the relationships with suppliers to provide stability. So that all makes sense. I think the plan is good. It's just implementing it. And I also think you're right about Gamesa and Siemens just having different cultures and different approaches to designing wind turbines. And it looks like that's going to come to an end. They're going to be under the Siemens banner and hopefully one big, happy, profitable company.
Get the latest on wind industry news, business, and technology sent straight to you every week. Sign up for the Uptime Tech newsletter at weatherguardwind.com/news.
Well, Rosemary, I came across this interesting article talking about gravity-based foundations. So over in France, they're working on a wind farm, the Facamp wind farm. I'm sure I'm butchering that name. There's 71 offshore wind turbines with, each of the wind turbines have a capacity of 7 megawatts, and they're Siemens Gamesa wind turbines. So they're using a slightly different kind of foundation. Here in the States, we've been using monopiles for the most part, but they're using gravity-based foundations, and that were assembled at a port near the final installation. These are less expensive foundations. So they basically have a concrete bottom and like a steel tube that pops out of the center of them, and they are quote unquote floatable. I guess some of them are floatable, but these in particular are put on a barge and drug out to the location, and a crane picks them up and just drops them to the bottom. But they use less material. I guess the only drawback to them is they have to prepare the sea floor to accept them. So you got to create a pad on the sea floor. So you may end up dredging the sea floor to make it level. So when the foundation hits the bottom, it's actually pointed in the right direction. It says oil and gas have used these in the past, and I have seen them in oil and gas, but I haven't seen them used in wind before. Does this make a lot of sense on some of these shallower depths of offshore wind? They're making these things up to like 150, well, up to 180 feet tall. So they're fairly tall. They're big foundations. But does this make sense just because it uses less materials?
Yeah, well, I mean, foundations isn't something that I know a lot about, but it is one of the most interesting parts, I think, of the offshore wind race. You know, there's all sorts of different technologies making their way from oil and gas over to wind, which makes sense because, you know, oil and gas industries had decades to figure out what works where and under what conditions. So, yeah, it's interesting design. It looks to me like just a giant concrete conical flask. You remember from, you know, your high school chemistry class, those conical flasks. And I saw they've got
something I tried to forget.
You know, I was famous in my high school chemistry for setting the bench on fire nearly every time fire was involved, and something would get set on fire. And I did continue that through to my professional career. I have been involved in a couple of burning incidents there too. So yeah, that's one of my special skills. If you want to know if your product can catch fire, then get me to test it, and I'll always trying to find ways to break products as fast as possible. You know, in the lab rather than in the field. And yeah, fire is one of my specialties. So anyway, they have a video on the website, on the article that I read describing it, that shows them, and they're nearly 5 tons each. So, you know, that's large. They're just, you know, kind of stacking them onto barges and dragging them out. And my immediate thought looking at them was, oh, this must be a less disruptive way for the seafloor. But as you point out, it's not just a matter of, you know, dragging it out to sea and just dropping it in the ocean and then it's done. There is a bit of preparation that needs to come first. So I'm not sure that they are actually any less disruptive, but certainly if they're using less materials, then that is going to be a benefit in the long run, especially now when, you know, we see commodity prices are so crazy and project costs are blowing out. So the less you're using, the less scope that there is for, you know, problems to happen. So yeah, looks interesting. And yeah, offshore foundations, definitely something I've got to get more into and learn more about, because there's so much different technology, and got to find out more.
Well, it makes you wonder if they're making these foundations for 7 megawatt machines. I'd assume you just scaled up for a 20 megawatt machine, because that's where we're going in the United States. I think we're pushing the boundaries there. At that point, when you have such large turbines, costs start to matter because everything grows exponentially, right? Kind of by the cube factor somewhat. So doesn't it make sense if you can put in less expensive gravity-based foundations, you're just going to do that?
Yeah, it's the square cube law that describes how you know things scale, and the topic of a recent video of mine. So thank you for bringing that up.
You're welcome.
It's a really interesting topic though, because, you know, people always think, oh, bigger is better for wind turbines. And one of the questions that I get asked constantly is, what's the optimal size of a wind turbine? How big are they going to get before it's, you know, optimized? And my opinion on that is that at any given moment in time, they are optimized. The size that manufacturers are selling is specially chosen to give you the lowest cost of energy. And then as things change, like either, cost of something comes down or a technology improves, then the optimum size changes. And so that, to me, is a reason why we see this divergence between onshore and offshore wind turbines. The offshore ones are not constrained by transport as much as onshore ones are. So, like an onshore wind turbine, its blades have to travel on roads. Usually its tower sections have to travel on roads. So they've got like a stronger phenomenon trying to keep them smaller than offshore wind, where you can just build your wind turbine blade or tower factory on the port, basically, so it never has to go on a road. And yeah, so that's why I think we see offshore wind turbines getting so much bigger than onshore. And yeah, so I made a video about it if you want to check it out.
Please do. Everybody should check out Engineering with Rosie. There's tons of great information there. I saw an interesting video on YouTube, of all places, that was off the Engineering with Rosie channel, because that's usually where I go every morning, is to see what's new on Engineering with Rosie. But ArcVera has posted a couple of YouTube videos, and one of them was of their CEO, Gregory Poulos. I'm probably mispronouncing that. And he gave it's an hour-long presentation, so you need to go to ArcVera's YouTube channel and go look for this webinar. But it was about offshore wind flow modeling, and they described some of the results of their research about how far these wakes can progress behind some of these wind turbine farms, and how one wind turbine farm can roll into another with its wakes. And when you put two wind farms simultaneously, one behind the other, the third one in line is really getting hammered, and it can be up to like 20% losses of energy. And having checked out that video, there's only been a couple of views on it, but that's an really important piece to offshore wind, to make sure that when we do develop these sites, that we're not losing energy, that we haven't, just like we talked about with Dominion Energy, if the capacity factor drops, they're in trouble with the state. Well, there's a number of times, and the predictions are really good, because they actually did the Bight area off the coast of New York, Rosemary, where they looked at what those wind farms would run into for several days. I think they looked at like 15, 16 different days from 2021 and modeled it with wind turbines there. It was remarkable how much energy loss there would be. On average, it's like 3-5% energy loss, which is a lot. And in some days up to 20, maybe a little over 20. So I just wanted to highlight that, because these wake issues, we're just getting the computational power and the techniques to do it. And during this presentation, they talk about the now old technique to predict the power losses versus this new technique that ArcVera has been working on. It's remarkable. You talked with Jessica O'Connor in San Antonio during ACP this past spring, and she I think she hinted at what this presentation is. Do you want to provide us a little more information about all the work that ArcVera was doing?
Yeah, so they have a wake model that they have developed onshore, and they've validated it onshore with real data. So it's a big giant model. I'm not sure if it's CFD, but some kind of atmospheric modeling, where they can predict how far that the wake persists behind individual wind turbines and wind farms. And they thought, like us, it's really interesting that there's all like so many new offshore wind farms planned in this one area, and thought, well, why don't we apply this onshore model we've got to this area of the ocean to see what's going to happen when all these wind farms are installed. And the results were surprising and gave a much higher loss in energy that persisted much further than you probably would have expected. I can't remember off the top of my head the figures, but it was, a few meters per second quite a lot of the time, depending on the wind direction. And I mean, the consequences of that, if it turns out to be true, are going to be pretty profound, I think, because people have paid a lot of money for the right to develop these areas.
Yes.
So some of the ones that have got, a spot in the ocean that is, particularly unfavorable because there's, certain prevailing wind directions. And so if you're, downwind from a bunch of a bunch of big wind farms, then you're definitely seeing big enough losses potentially that your business case would be shot. And then also, I think it's interesting to refer back to, this idea, we talked about the idea of having a capacity factor guarantee from the Dominion project, and that's not going ahead. But the normal way that people do performance guarantees is, with some sort of algorithm based on the wind speed. And I think you'd want to be really careful if you've got a performance guarantee like that. You're going to want to be really careful to specify exactly where the wind speed is measured, because, if you're measuring it at, some existing met station that isn't very close to your wind turbines, you might see much higher wind speeds there than what your wind farm is actually seeing. And you could end up, with really severe penalties for underperforming. So that's interesting. I haven't watched this webinar yet, and I will because I find this topic really interesting. It's something people ask about a lot. Yeah. But the last, when we talked to Jessica, they hadn't validated it offshore yet. And I assume that's still true because, unless they're going to Europe, it would be hard to, you can't validate it in the US yet, at least because the wind farms
sort of
don't
what
exist.
They did.
They're in planning.
Yeah.
They did go to Europe, or
they talked about he was showing images from Denmark, where that's where the biggest offshore site is. Yeah. So they were showing comparisons between, here's the clouds in Denmark across Horn Rev site, and this is computationally what we come up with. There's an alignment there. It's pretty accurate. And one of the things that Gregory was talking about was the inversion layer. When air is stable and you get an inversion layer, which in the States you get in the mornings and evenings, probably like most places in the world, where like if you have a chimney and it puffs up smoke, it gets up to a certain level, just kind of hangs there and stops, doesn't rise up anymore. When stable air, these wakes can get really strong. And that's one of the things that their model now incorporates is air stability. So they need a whole bunch of supercomputer time to get these models to run. It's really computationally intensive because the atmospheric models and the meteorological models are so integrated, and then you're throwing in wind turbines and wakes off wind turbines. You can imagine how much computer time that must take to do that. And this is the first time I've seen this level of a presentation about wake turbulence offshore. It's remarkable. And they walk through, like you were saying, they walk through the economics of this, of here's how many gigawatt hours of energy you're likely to lose if you're in this site in the bite area. It was remarkable. And that needs a little more exposure. Like you and I have been talking about, some of these projects become profitable at the slightest little margins. Wake vortices can be a big impact there.
Yeah, I better have them on a live stream. I better invite them on a live stream of Engineering with Rosie to because it's something I get asked about a lot. And also, you see modeling pretty frequently. People do modeling of vertical axis wind turbines. That have the feel of this. It feels like those are similar analyses to what they've done here. But and they always get reported very, very widely because the results will usually show, vertical axis wind turbines are 5 times more efficient than, at capturing energy out of an offshore area. And my criticism for those models is they're always two-dimensional. They're never validated against, real offshore wind farms because, there aren't any big vertical axis wind turbines even onshore anymore. So I always take those results with a grain of salt, whereas this one, at least their onshore work is very well validated, and it sounds like I have to obviously watch this webinar to find out what the validation they've done now for offshore, but it sounds like they're starting to validate that too. So, it's actually something worth paying attention to in this case, because what I found with in my PhD research, I did a little bit of CFD because I needed to get some load distributions for structural design of wind turbine blade. And while I was, learning how to set up my CFD model, I found you tweak the parameters right, then you can get any answer you want. So if you don't have a way to validate your analysis, then it is absolutely meaningless. And it's the most common cause, I think, of people thinking that they have some, breakthrough energy invention that, maybe it exceeds the Betz limit or breaks the law of thermodynamics. And it's usually because they're they think too much of their CFD model. So yeah, validation is the key to that, and that's what really sets this analysis apart.
So the YouTube channels to subscribe to, probably in order, really: Engineering with Rosie, ArcVera, and then if you have some time, you should subscribe to the WeatherGuard Lightning Tech channel, where you can watch uptime, the uptime videos, which are really helpful. Make it part of your routine every week.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS, so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
Well, we are at WindEnergy Hamburg, in Hamburg, Germany, of all places. And we're here with Nicholas Gaudern. Of course, I got my co-host Joel Saxum from Wind Power Lab. And we're at B6494, which is our home for the next 3 or 4 days, where we're talking all things wind energy and wind turbines and wind turbine blades. And it's this Nicholas from PowerCurve has joined us. And Nicholas has PowerCurve, all of a sudden, just before the show, I was on my phone and like, oh my gosh, they've got a brand new logo on LinkedIn, and oh, look at this brand new webpage. It's actually a huge improvement. It has a ton of information on it, which I always want to see.
Yep.
You want to explain the new logo, what's going on? And
absolutely. It's been a long time in the making, as new websites often are, but we knew it was time for a refresh. We weren't really reflecting all of the offerings that we have to the market, and I don't think we were kind of giving people enough clues about what to expect from working with us, you know, and the service we provide and the level of dedication we have to our customers and making their turbines better. So we really wanted to sort of have a bit of a clean sweep of everything, make sure the content was fully up to date, and just showing all the great stuff we're working on. So we have a new color scheme, we have a new logo, just a whole new visual identity.
Rebranded and ready to take over the world?
Something like that.
Yeah, debuting here at in Hamburg at WindEnergy Hamburg.
Yeah, the website launched yesterday. We wanted to make sure we were just in time for the show, and already we've had some great feedback. Yeah.
So, question for you: one of my favorite features of your old website was the AEP calculator that you had on.
Yes.
Yes.
Is it still there?
It is still there.
Fantastic.
It is still there, but it's been made even more user friendly.
Oh man, look at you.
So you can go through that. You can look at the kind of business cases you might expect from installing our upgrades. So look at the payback periods, the extra energy you're going to get generated. And it's just now much more easy to navigate, to give you that kind of quick check on how much money you are missing out on making.
Right, yeah, exactly.
Well, that's a big topic of discussion, even on the floor here this morning. Today's Tuesday, so it's the first day of the show. And many customers have come by already talking about, my blades have leading edge erosion, my blades aren't making the power they're supposed to. It seems to be a pretty constant theme for the show at this point. What are some of those things that PowerCurve can do to get some of that performance back?
Yeah, well, there's a few different avenues we can take depending on what the customer wants and what fits best with their operation. So we have like a hardware leg, let's call it, where we look at offering various solutions to boost performance and to recover energy that's being lost from the turbine. And the key product for that is vortex generators, and they can be used in lots of different ways to improve the performance of a blade. So that's kind of the solutions side of things, where it's very much focused on getting equipment onto the blades to make them perform better. But we also now spend a lot of time on digital services. So we have a number of tools that we can deploy to help a customer understand the state of their blades and what it means for their production. So if they have damages on a blade, defects, if they have LEP, what is that doing to power performance? And is it being done in the most optimal way? What can be done to improve it? Yeah, this digital service aspect of what we do now is becoming really big, and we're getting a lot of excellent feedback with the customers we're working with.
Is that the service that you're offering with SkySpecs?
That is one of them, yes.
Okay.
Yeah, so the SkySpecs service that we call the erosion evaluator. That is a service that is offered by SkySpecs, where all of the SkySpecs data, so all of the structural inspection data for any defects or damages on the blade, that is all processed, tagged, categorized, and then PowerCurve use all of that information along with a very detailed aerodynamic model of the turbine to calculate the AEP loss from those defects. So you then have this amazing tool that says, what am I losing on a turbine-specific basis due to erosion and damages? And then that gives you this very powerful tool to say, well, which turbine should I fix first? What should I prioritize? What should I do with them?
Yeah.
You know, no one's got the money all the time to repair their turbines, all turbines every year.
Right.
You need a way to prioritize.
So a question that Alan and I talk about the differences a lot of times on the show between the European markets, the Scandinavian markets, British markets, the U.S. market, and how asset owners treat things differently.
Yep.
Do you see with those new digital services a difference in who's actually asking for them? Is it a lot of people in the U.S. market? Is it a European market? Who's focusing on that from an asset side?
I would say we have customers in both the US and Europe who are quite focused on the digital services. I would say that the US is more interesting at the moment in terms of the requests we're getting. And I think that tends to be because the wind farms tend to be so much larger.
Yeah. So that 1% means a lot to someone with 200 turbines out there.
Exactly, and you really do need to prioritize your repairs just because you have so many turbines to deal with. So, I think the US is probably a key market for that erosion evaluator service. But I think this kind of digital service approach, digital twins, really deep understanding, I think all the operators want in on that now, because the OEMs are not making their lives easier. The OEMs do not want to share aerodynamic data. They do not want you understanding AEP loss. So I think we have a great opportunity there to educate.
Yeah,
basically.
absolutely. When people need something, they're kind of playing around with, I know there's something here, I'm not sure. Call the experts.
Yes.
Right? You when you need to fix your car, especially these brand new ones with all the electronics and everything, and you're like, there's something around here. I'm going to the dealership. Like I know I'm going to go and take that someone that knows what they're doing. So
no, I think we have a really, I would say, unrivaled expertise in blades, and that's not being big-headed too much. I don't think it's driven by the fact we've looked at so many blades. We don't just look at Vestas blades. We look at all blades: Vestas, Siemens, GE, whoever. And that just gives us a very unique perspective that I don't think a lot of people have. Understand
all the nuances and how they can play together. And if this blade has a little bit of this design, when we go to adjust this blade that's having an issue that's similar to that one, we could adjust this.
Yeah, we can draw on that experience and track record. Yeah.
So one item I want to get to that is new on your website is AeroLightning.
Yes.
And so we're introducing this whole new concept to the world this week, which is a combination of lightning and aerodynamics, which doesn't seem obvious at first. And it's just been a partnership between WeatherGuard Lightning Tech, PowerCurve, Wind Power Lab, and also Matthew and Ping down in Australia on the monitoring side. But the key feature about understanding what's happening with lightning is, in part, the aerodynamics around the LPS system, because it's not obvious that turbulence can cause problems for the LPS system.
Yeah.
And as you've done a number of CFD analysis on different blades, the LPS systems are almost always in a really turbulent area, even new from the factory. You want to describe that a little bit?
Yeah, and the AeroLightning thing is really exciting. And I remember one of the first conversations we had, Alan, quite a long time ago now, where you were kind of throwing some questions and problems at me, and we were sparring about it, and suddenly things started clicking, right? That you cannot separate aerodynamic behavior and aerodynamic performance and the effectiveness of a lightning protection system. And I think up until this point, they're just treated as two completely separate boxes with different needs and different requirements. And actually, there's so much overlap that you have to consider them together. And what we found pretty early on is that if you look at the flow around the tip of a blade, you can get some very complicated three-dimensional structures. I think a lot of people listening will know that you have quite a large vortex that's shed from the tip of a blade. That's a very complicated 3D flow structure that drives other 3D flow structures around the tip.
Right.
The tip is also the bit of the blade that gets damaged first from erosion and contamination and things like that. So suddenly you have a very sub-optimal surface, let's call it. You have a large vortex structure. You have a design that probably hasn't had an awful lot of attention paid to it because most blades are designed in a predominantly two-dimensional design space.
Right.
So what all this comes together to mean is that you have a very complicated system of flow structures around the tip, and you have a lightning protection system that is trying to kind of, you maybe phrase this better, but kind of like, throw ions out into the air.
It is, yeah, sure.
And they're going to get dispersed.
Right.
They're going to get blown around by this highly turbulent and intricate flow structure we see there. So if that's happening, you're not going to get effective lightning protection. You're just not going to get enough strikes hitting where it's safe to do so. So on that receptor pad. So what we found is that if you work hard to control the flow around the tip,
Right.
then you're going to make your lightning protection system much more effective.
Yeah, and that's the key. Is lightning is just hot air.
Yes.
And it's affected by the airflow of the wind turbine. It's affected by the wind. And if your LPS is in a position where there's a lot of turbulence, you got to remember that the blade is rotating 90 degrees, 120 degrees, because lightning is relatively slow. It may take a half a second, maybe longer in that time, to attach and to travel behind it. So lightning is constantly chasing the blade around the arc. It has a hard time to do that if it's very turbulent. And lightning will find a place to go. It's already traveled 4, 5, 6 miles to get to the blade itself. And it's looking for this last meter or two, and it will find a home one way or another. And what we're seeing is that the aerodynamic data correlates with the lightning damage data. It's very shocking in a variety of different ways. So as a lightning engineer, the first thing we look at is where's the lightning attaching? And the question I get all the time is, well, why is it a meter from the tip? Well, it turns out that it's a meter from the tip because that's where the air is clean.
Yeah, exactly.
Yeah, exactly.
It's a big difference.
And I think, the more we looked at it, the more kind of obvious it became that there has to be a link between these two things. And we talk about that on the website, and we now have this partnership with UL and the other parties. And I just think there's this real opportunity here to make a step change in understanding and mitigation of lightning protection. Yeah. Because for too long, it's just involved zapping things that are stationary on a test rig. That's not good enough.
Yeah. No, as we found out, it's not. Right, all the IEC testing that's done, and there's a lot of IEC testing done, particularly on new blades. Yep. And that's always very successful. At least the information I get on new blades is we pass the IEC test, which it should. But when they get in service, the results are totally different.
You're talking with these brand new blades, clean surface like this table we're sitting on, right? Everything is nice. The corners are, the leading edge looks perfect. Everything, and the wind flows a beautiful way over that, or the air flows a beautiful way over that in a CFD analysis in the design phase or right out of the factory. But if you put that blade, as soon as, 1 year in, you're already getting erosion on the tip. 2 years, 3 years, 4, 5, 6. And if it's not maintained, all of a sudden that tip is... You're not getting near the same CFD analysis if you did it again with all those damages and erosion and all those things. So you get this dirty air, and this is what the AeroLightning product fixes.
The default place to put a receptor is maybe half a meter, maybe less, maybe even less than that, away from the tip.
Yeah, right.
So you're putting it in the most challenging area for the lightning to make that connection.
Right.
So, and that's what we see. We see so many strikes that are occurring, as you say, 1 meter, 2 meter, 3 meters away from the tip. The lightning wants an easy life.
It does. It needs one.
It needs one.
Yeah, it needs one. Totally.
You don't see, from the wind power lab side of things, we're always looking at bulk data, right? We're looking at a wind farm's full of inspection data. What does it look like here? What does it look like here? And when you see a wrong lightning attachment, it's never on the tip.
Right, it's somewhere else.
Yeah, it's usually they're usually in these weird spots, and we're like, why prior to these conversations and going through this, why does this always seem to happen in this spot? Well, it's where the air finally got clean. Yeah, and it's as simple as that.
Yeah, and I think that's the really important key here is when we start looking at lightning protection. We have a lot of people just this morning reaching out about lightning protection on blades that had massive damage, hundreds of thousands of dollars of damage to blades.
my first response is we need to look and see what the CFD says about your blades, because we would love to put strike tape on everything. I mean, that's our core product. That pays the bills, right?
Yeah.
But we're not going to do it until we are sure that we're going to have the maximum lightning protection we can provide, and that requires some CFD analysis and talking to WindPower Lab about the blade structure and what's happening on the inside that we need to know about.
It's a system, right? It's a complicated system. It's a complicated system. You have to look at it as such.
Realistically,
Yeah, it's one of the more complicated systems, maybe besides blade de-icing. Those are probably the two most complicated systems because they touch so many areas that it's a very difficult challenge. I think we're finally up to the challenge now. I think this team here is going to be able to deliver on what we're talking about. And every customer you've talked to over the last week or two or three is really engaged with it because it makes sense. Finally, lightning makes sense. That's why I had a lightning strike right there.
Right.
Yeah, that's right. It seems obvious now, but a year and a half ago it wasn't obvious.
No, not at all.
Yeah.
You're starting to see the one of the reasons this product comes up as well as the markets are starting to adjust to it. The insurers, at some levels don't want to insure some lightning protection systems because they don't work, right? So this is a way to solidify that market and take the risk out of it, and in the whole scheme of things, it lowers the levelized cost of energy for everyone. Because the insurance premiums can come down, people can get back on risk. The operators aren't, a blade folds. If one blade goes and it folds over, maybe it hits the tower. Maybe you just have to replace that one blade. If you have to replace all three blades because of weight certificates or something, you're talking $1.5 million.
Right.
And whether that's on the insurance company or the asset owner or the OEM, that raises the cost of energy for everybody.
Yes.
Right. So if we can do our part by lowering everything in the market and reducing that risk, it's a win.
Absolutely. And that was, again, another thing that happened this morning was the number of times, it was 3 or 4 times just this morning where potential customers or people experienced in the industry were talking about insurance, how they're in a fight with the OEM or they're in a fight with the insurance company because they had a lightning strike, and the lightning strike caused a bunch of damage, which it doesn't always do, but when it does, it becomes massively expensive. It's not a quickie fix, as WindPower Lab knows.
Yeah, absolutely.
They can be a lot more deeper inside, and then those get super expensive quickly. So there's just, hopefully we're adding to that conversation, adding to the discussion, and just raising awareness. And I think that's probably the most important part. This is why I like the website, by the way. Just because it starts to tie it together.
Yeah, and that's what we just realized that we were very focused on a product for a long time.
Sure.
And our main product was vortex generators, so that's fine. But, it's just so much more than that. It's about that relationship with the customer. It's about sharing knowledge and understanding and building a trust that we know their blades better than almost anyone else.
Right.
And that means we can offer the solutions, we can offer the consultancy, the digital services. So we've got all these things in the toolbox that allow them to know their blades better than the OEM. It's a bold claim, but I mean, I think compared to the state now, general state, I think it's probably fair.
I think a lot of OEM customers would agree with you.
Yes, yeah,
at
exactly.
this point, And it would just walking around the floor, we got a preview last evening to walk around the different places of the floor. There are a couple of other companies that are offering blade add-ons, but here's what I see that makes PowerCurve just completely different than the majority of the rest. It's the ability to understand what is actually happening on the blade and to do that CFD analysis and to have the actual blade scans, not a theoretical model of a blade, but to scan a blade, get the real blade, and do a really tight analysis so that what you see on the computer screen is actual. Better, probably it allows you to do those little fine details in terms of like VG placement that get you another 0.5 percentage point.
Yeah, I completely agree. And it's a lot of the devices, particularly vortex generators, they're well known, right?
Sure.
They've been around a long time. OEMs use them. So they're a proven technology, but that kind of doesn't really do the engineering justice. Yeah, they're proven, but that doesn't mean you can just chuck them on the blade and they work. You have
we've seen.
Yeah, as we've seen.
Yes.
You have to do a lot of very careful and diligent engineering. You have to understand the root causes of the problems. And that involves getting real blade geometry and doing proper modeling and proper analysis.
Yes.
And just take the guesswork out of it.
Right.
And that's what we spend our time doing.
Right.
And sharing that with the customer.
Yes.
We'll share our CFD results, we share our modeling results. There's nothing hidden. we want to have that conversation and be open, because then everyone wins.
So having that customer be involved with the process is huge, because they don't tend to be CFD analysis people.
But what they do know is they know the performance of their turbines better than anyone.
Right.
They know what's going wrong with them. They know the nuances of each machine. They know the local climate conditions and the service histories. And so we take all that in. We listen to them, and we take that into our analysis and our design process when we're designing the kits. And I think that is what sets us apart, that attention to detail and that focus on listening to what the customer knows. And they know a lot.
They do.
They know so much. Yeah. So we take it all in.
Well, Nicholas, it's been really great to see you in Hamburg. We get to see each other occasionally at conferences. So it's like 3 or 4 times a year we cross paths somewhere on the planet. So it's good to see you again. I'm really excited about the website. Congratulations on the website. And congratulations on all the CFD work you've been doing on AeroLightning. So it's been a busy couple of months, but you made it to the show. That's congratulations. So it's great to see you again.
Yeah, it's great to see you too, and you too, Joel. And I'm really glad you liked the website. You must have been one of the first views, I think.
I gave you the thumbs up real quick. It was awesome.
So I hope some of our listeners will check it out as well. So there's a lot of really nice information on there.
We'll put the link in the show notes so everybody can see it.
That's going to do it for this week's Uptime Wind Energy podcast. Thanks for listening. Please take a moment and give us a 5-star rating on your podcast platform. Be sure to subscribe in the show notes below to Uptime Tech News, our weekly newsletter, as well as Rosemary's YouTube channel, Engineering with Rosie. And we'll see you here next week on the Uptime Wind Energy podcast.